Students, is my screen visible?
Yes, ma'am.
And slides?
Yes, ma'am, slides too.
Thank you. So we will start the class in another. Wait, okay. So good evening, everyone. I'm Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTL, and whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputri from ICER Pune. So, students, in this week we are going to cover problems based on enol and enolate chemistry. So, problem number one for you is ketoenol tautomerism is observed in which of the following? Can anyone tell me what is ketoenol tautomerism? Ketoenol tautomerism. Okay, before that, tell me, let's say this is ketone, okay, and this is your enol. Can anyone tell me among this ketone and enol, which is stable and why?
Ketone due to more bond strength.
Just give me 1 minute. Huh. Sorry for that. Now tell me, among this ketone and enol, which form is more stable and why?
Ma'am, keto form is more stable.
Keto form. Okay. And enol is someone
Ma'am,
in
lesser stable.
lesser stable. Why?
Ma'am, due to the double bond, carbon oxygen double bond in keto is
Exactly.
the bond
That
strength.
C double bond O bond is, let me write here. Bond strength of C double bond O bond is greater than C double bond C. Then why in some form enol is more stable? There we will see the factors responsible for that. Let's say if I am talking about this molecule. Obviously, this molecule will be more towards its enol form. Why? Because its enol form is aromatic. Yes or no?
Yes, ma'am.
In this case, enol form is bringing extra stability here. That's why enol form is more stable. Extra stability in terms of aromaticity. So, keeping these things in mind, what you have learned is for ketoenol tautomerism, a compound should have alpha hydrogen. Okay, because definition of ketoenol tautomerism says it is 1,3 hydrogen migration. 1 3 hydrogen migration. How 1 to 3? You can number from any side. Let's say 1 2 3. So carbon number 1 is having 3 hydrogens. So 1 3 hydrogen migration. So this hydrogen is shifted to 3. Carbon number 1 hydrogen shifted to atom 3. Yes or no? So this is your tautomerism. Now tell me, enough answers I have given. Now tell me which is the correct option.
Option two.
Yes,
Why?
ma'am. Option B.
Because it is having alpha hydrogen
Alpha.
and other options doesn't contain any alpha hydrogen. Clear? So you can get these type of questions from here. Now your next question is the order of enol content in the following molecules is order. They are asking about order of enol content. So for solving these type of questions, first make their enol form. Then we can decide. Okay. You also draw. I am also drawing.
Ma'am, option A.
Obviously, in this 1-3 type system, only one of the ketone we can write in this form. This is its enol form, yes or no? Another possibility in this case you can think of, this is also possible, right? Sorry for my voice today. This is also possible, yes or no? And one more possibility is there, students. This can also show 1-3 hydrogen migration, yes or no? Because alpha carbon is having still hydrogen. So another possibility is clear.
Yes, ma'am.
Okay. On basis of ketoenol tautomerism definition, can I draw these three structures? Any other possibility you can see of making enol here in A? Is this not possible? Okay, before telling me answer, just tell me one thing. Can you make enol of any ketone? You can make, na? You just have to take alpha hydrogen, transfer to it oxygen, and put double bond there, right?
Yes, ma'am.
So these are four stable. Among these four enols, which is most stable? Obviously C.
Third one.
Huh. So one thing is clear. That this A can have two enol forms possible, right? One is from this side and one is from this side. So obviously this will have maximum enol content. Yes or no? So option in which
Yes,
A is
ma'am.
in front. Oh, every option have A in front. But I hope you got the understanding of this, that why A is having maximum enol content. Okay, this is about A. Now let's talk about B. What do you think? Listen my question first and then answer. In B, which form will be more stable? Its keto form or its enol form?
Ketone form.
I couldn't
Ma'am,
listen.
Keat.
Huh, what?
Ketone form.
See, now you will ask, ma'am, when enol form will be more stable than its keto form. So my general answer to this query is, in general, your keto form is more stable than your enol form. But factors which can make your enol more stable than ketone are resonance, conjugation, both are same thing, or your enol form is bringing aromaticity, or your enol form is having any type of hydrogen bonding stability. In those cases, your enol form will be more stable than your keto form. But in B, there are no any condition which can make it more stable. Yes or no?
Yes, ma'am.
Okay. So one thing is also clear, that B will be in last. Okay. So which option have A in front, B at last? A and B. Okay. So you can easily delete option number C, option number D. Clear? Now we have to decide between C and D. Right? Okay. Let's make a student. This is double bond, I think. Okay. CH3, CH. C. No, no, it's single bond. A single bond. Its tautomer will be either this. Okay, one possibility is this. Another possibility is CH3, CH, CH, OH, this, right? And this D will have CH3, C, OH, double bond, C.
Ma'am, here in the carbon chain, is there, I mean, the C1.
Wait, students. Huh. Now you can ask what?
Ma'am, here in C, the carbon chain is having, I think, ma'am, this double bond, single bond means the valency is not completed here,
Yes,
no?
I am also having confusion it. My gut feeling is here double bond was already there. Only then, okay, let's check. Wait, one from this side, two from this side, and
And even 5 carbon chain should be there, and we have written 4 carbon chain.
okay, my bad. Sorry, my bad. Good. I think this is correct, na? D1. Yes or no? Is D correct or not? This is
Yes,
D.
sir, correct.
Okay. And C is this CH3. But tell me one thing, will is this double bond here or not? Okay. CH3, C double bond C OH CH2. Now tell me which type of arrow should I draw in between these two structures? Hmm. So this is your C. Now tell me in C which form is stable, above one or below one? Students, can
Below
you,
one.
huh? Above one, below one, right? So your arrow will
Be-
be like this,
yeah,
more towards this side, small towards your reactant side, okay? But among C and D, which will be more stable and why?
Ma'am, D
Yes, your D, what? Your D, enol
should be
content
most.
will be D, enol content of D will be more than your C, right? Why?
Yes, ma'am.
Because here double bond is in conjugation with your carbonyl, and here double bond is conjugation with any other double bond, right? So correct answer is A is having maximum enol content, good, and after that D, then C, then B. The correct answer is A. Everyone is with me or not? If not, give me reason.
Ma'am,
Huh? Ask.
Ma'am, just I want to ask that in this A option,
Hmm.
ma'am, we have drawn the 4 different enol structures for that.
Huh.
So these are the total 4 we are drawing, or only the C only we are going to accept. And this is most stable one. So
No, if anyone asks you what are the enol possible in these cases, you have to draw all the enols, and these all are in equilibrium with each other. You can't say only C is the tautomer of it. These all A, B, C, D, all these four structures are in equilibrium. Let's say you have this compound and you are taking NMR, है ना, 1H NMR. You can see here, you can see in proton, you can see all four will be there. How? There can be two OH peak also, one OH peak also. Okay, so all these are in equilibrium. You can't
And
say.
for yes, ma'am.
Huh.
And ma'am, for diketone structures,
Hmm.
one of the possibilities should be converting them both the ketones into OH. No?
From terminal side, right?
Yes, ma'am.
That is also
Like here.
possible, but I have drawn here most stable enol form.
Okay, ma'am.
That is
Yes, ma'am.
also possible.
Understood.
Yeah, you are correct. So others, I'm again clarifying this thing. There are various enol forms possible here, but for example, in case A, this is the most stable form, which is taking this A option in front. Why? Because due to structure C, the order of enol content is maximum in it. Okay. B is normal. C is having resonance with double bond, and in D, resonance is with your carbonyl. So this is more stable. Okay. So correct answer
Okay.
is A. Good. Okay. Again, same type of question. Maximum enol content is in which option? A is your acetone. B is your. You just have to see stabilizing factors which are making enol form more stable than your ketone. Okay.
And second option.
Second. Okay. Why not fourth? And okay. Forget about one and option number one and three. Why not fourth?
Ma'am, I'm seeing the a number of alpha hydrogens also for that.
Exactly, exactly. See, students, if you draw others also, are you getting how to see the enol content or how to see or how to make enol first? Everyone, wait, who else is?
Excuse,
Huh, Bhumika, yeah, ask.
ma'am, we decide the the order of enol content on the basis of stability or number of enol structure possible.
Good question. Um, both factors are responsible for it, but major contribution is from most stable structure of that enol. For example, in case A, that aromaticity is bringing that structure A having more enol content. Okay, but yeah, more number of enol structure possible, more is the enol content. Good. This is also a factor possible for that. Clear?
Yes, ma'am.
Others, you all can draw now how to make enol form 1,3 hydrogen migration. Wait, let's get back to slide. Okay. So this is your simple ketone, right? If anyone says just draw its enol form, so how you have to do? Okay. Are these two structures resonance form of each other? If you know
No,
the
ma'am.
rules of resonating structures. No, na why? Because in drawing resonating structure, you can't change the position of atom, right? Here, hydrogen is displacing from carbon to oxygen. These are tautomers only. And how to see they are tautomers or they are showing ketoenol isomerism by 1,3 hyd. Wait. By 1,3 hydrogen migration. How? 1, 2, 3. You just have to take this bond here like this and this single bond OH. Okay. In and due to alcohol, enol. Okay. In first structure, only one enol is possible like this. In second structure, two possible. How to approach these type of question? Draw every enol possible. Okay. And at last, we will see stability. One is this possibility, another is this possibility. If I am leaving behind any possibility, you just inform me, okay? And in this possibility, okay, sorry. and in fourth, this person. One possibility is this. One possibility is this. Any other possibilities there in option number 4? Yes, na?
Yes, ma'am.
From this terminal position.
Left side.
Huh. Now tell me which is having maximum enol content. Option number 1 and 3 are out. Decide between option number 2 and 4.
Option 2, ma'am.
Okay, another thing, tell me. Okay, let me number it. In A, B, C, D, and E, which enol is most stable and why? Okay, let me reframe my question. How to check enol stability? You have to check stability of enol by checking stability of that alkene formed, right? If you see here, in this conjugation is not there, so it is out, and here also conjugation is not there, it is out. So now you have to compete A, C, and D. Okay. In A also conjugation with carbonyl, conjugation with carbonyl, conjugation with carbonyl. Okay. Now check hyperconjugation. 3 hyperconjugation. Here how many hyperconjugation? 3. Here how many hyperconjugation? No hyperconjugation. 0. So D structure is out. Now compare between A and C, which is more stable. Okay, next question. Among ketone and aldehyde, whose carbonyl is having more electron density?
Ketone.
Ma'am, ketone.
Ketone. So A will be more stable than your C, therefore maximum enol content will be in your structure B. Understood? Now, Bhumika, let's come to your statement. You were saying, let's say, ma'am, you will say, ma'am, in this condition, only two ion structures are possible, but in this condition, there are three possible. But first, at first priority, you have to see stability, and here, this conjugation, this enol form of aldehyde is less stable than enol form of ketone. You can write this point. Enol form of ketones are more stable than enol forms of aldehyde. Why? Due to hyperconjugation. Yes or no?
Yes, ma'am.
That alkene which is forming as a result of tautomerism is having more hyperconjugation. So correct answer is option number 2. I hope you all understood. Okay. Very easy questions. One by one, everyone can tell me. Okay. In first, who is going to tell me? They are asking number of alpha hydrogens. If you draw its structure clearly, it is CO, CH3, CH3. Now tell me number of alpha hydrogens.
6.
Very good. In
Yes, ma'am,
second,
6.
I see this is very easy question. I want answer of this question from each of you. I want different faces. Other students, please tell how many alpha hydrogens are there?
Three.
Boys,
3, ma'am.
good. Why so tired? Josh is low.
Network problem, ma'am.
Okay. How many alpha hydrogens here?
Zero alpha hydrogen.
Exactly. If you are calculating alpha hydrogen means you can write alpha. Alpha hydrogen denotes hydrogen attached to carbon next to carbon. Hydrogen attached to carbon next to carbon. Okay. Now tell me in D, how many alpha hydrogens?
0.
Zero.
Very good. In E, 2 pentanone.
5.
Five alpha
5.
hydrogens.
Wow, very good. Um, and then in F,
Four.
4.
good.
4.
So one thing is clear, you can all can count alpha hydrogens. You all can form enol. You can see stability of enol by hyperconjugation or resonance or aromaticity. Good. Rank the following carbonyl compounds in order of acidity. Okay. Let's recall our previous class. How to see acidity? I have told you the proper sequence in which you can decide acidity of any four molecules given to you.
Stability of conjugate base.
Very good, very good. I have told you that more stable will be your conjugate base, more will be the stability of that acid. And how to see stability of that conjugate base? First, by size, electronegativity, resonance, hyperconjugation, inductive. Okay. If you see that thing here, they are asking rank the following carbonyl compounds in order of acidity. So, okay, they are asking about acidity. Can anyone tell me which is the most acidic proton in one? Obviously, hydrogens attached to alpha carbon, right? Because let's say if we are conjugate base forms, it will be in conjugation with this carbonyl. Understood? Okay. So here students, if base subtract proton from here, it can have two resonance, right? So this conjugate base is more stable. If I am saying conjugate base of second is more stable than first, am I correct or wrong? Okay, let me repeat.
Correct.
Con- okay, network has reached, huh? So, conjugate base of second is more stable than first due to more conjugation, right? So, one thing is clear, second is greater than first, okay? In third, again two conjugation. In fourth, again two conjugation. Now, tell me among third and fourth, which is more stable?
4th.
Yes, ma'am. Fourth.
Sure.
Yes, ma'am, because lone pair of oxygen will also participate.
How?
Ma'am, lone pair of oxygen will participate. So in 4th, there are 2 oxygen more where lone pair can participate.
Okay. Let's make what you want to say. O, CO. In one case, you will get this OH, or I can make enolate, right? As it is carbon ion. Okay, and another case you are having CO. Now tell me, among these C and D, which double bond is more stable and why?
Anhydride form.
Huh?
In an anhydride form, ma'am, double bond is more stable.
See. how I'm looking at this question, you have to make this carbanion stable. How you can make any carbanion stable? By putting any electron withdrawing group sidewise to it. One thing is clear, resonance is decreasing that negative charge, therefore it is stabilizing. Now tell me, students, if I ask among this carbonyl, sorry, actually it is not going. Huh. Now students tell me, let me use laser pointer. If I ask you, student, this carbon is more electrophilic or this carbon is more electrophilic? This carbon. I'm asking among A and B, which carbon is more electrophilic? Which carbon is more electron
Ma'am,
deficient?
A.
A. Exactly A. Because in B, this oxygen is assisting this carbon, right? So A is more electron deficient. So obviously negative charge nearer to electron deficient carbon will be more stable. Yes or no? Therefore, students, therefore, second will be more stable carbon ion than your fourth. So exact order will be 2, 3, 4, 1. If not understood, ask me again. I will clear your doubts.
Yes, ma'am, I did not understand.
Okay, let me explain you. See, one thing is clear that you have two conjugation in every case, right? This is clear, na?
Yes,
Okay. Now next thing comes is I'm asking among this carbon number A and carbon number B, which is more electron deficient. I'm asking about carbon. Obviously, electron deficient will be A because here CH3 is not assisting that much as this oxygen is assisting this carbon. Because let's say
yes,
this is clear na that ketone carbon is more electrophilic than your ester carbon. Ketone,
yes, ma'am,
huh.
understood.
Therefore, your ketones will be ahead than your esters. Therefore, correct answer will be 2, 3, 4, and 1. Now understood? Students, here they are asking about acidity, not keto-enol form. Again, read the question carefully. Here they are asking rank the following carbonyl compounds in order of acidity. So here you have to check the stability of conjugate base. Conjugate base means you have to check the stability of anions, right? They are not asking which enol form is more stable and which is not. They are asking their acidity, and acidity you have to decide by stability of conjugate base, means stability of that conjugate anion formed. Understood? note
Yes,
down
ma'am.
note down in your copy that active methylenes of aldehydes will be more acidic than ketones. They will be more acidic than ester. Let me write here, it will be good for you. So, from this question, I want to conclude that please keep these two things separate, enol content and your acidity. Okay. What I was saying, acidity of active methylenes of aldehydes will be greater than ketone, will be greater than ester. So, rank in order first is 1 is equals to most. Okay, that we have done. Students, clear or confused? If still there are any doubts, you can ask me. Doubts? Bhumika, Dipali, any doubts?
No,
Ma'am,
ma'am.
negative charge can be stabilized by conjugation as well, no? So
Huh?
lone pair can participate and stabilize it, then why we are looking only electrophilicity?
Okay, see, conjugation, if you are talking about conjugation, here conjugation is with carbonyl, here also conjugation is with carbonyl. But that is another factor that we are drawing its resonance form. But if we look at the stability of this carbanion form, because from here that proton is going, in which it is accounting for its acidity, and this carbon is just adjacent to this negative charge. So by this factor we are deciding. Okay,
Yes, ma'am.
I hope you understood. Okay, which of the following is the structure of most stable enol form of 2 methyl pentane 3 on? Okay, what you can do is, in problem number 5 now, whatever structures I have given to you, you just read in Claydon about these, or you type in Google these structures name and find pKa of these. And in next class, please discuss pKa of these compounds. Then on basis of pKa, we will decide their acidity again. Okay, you can do this now. You just have to
Yes,
find
ma'am.
pKa values of all these carbonyl compounds. We will discuss in next class. Okay, good.
Okay, ma'am.
Okay, good. Now tell me, among these all the structures, which is the most stable enol form of 2-methyl pentane 3 on? Okay, let me first draw pentane 3 on. One, two, three, this. 3 here, 2 methyl. Okay, this. Okay, this is your 2-methyl pentane 3 on. Okay, let's check here. Is first you have to check whether it is its enol form or not. So first answer this question: is this enol form of pentane 3 on? Yes, yes,
Yes, ma'am.
it is. And now our next target is to calculate hyperconjugation. So 3, 3, 6 or 2, 8 hyperconjugation. Correct? Here 1, 3, 4 hyperconjugation. Okay. How I am calculating this? If in order to calculate hyperconjugation, you have to see hydrogen attached carbon next to your sp2 carbon. I'm repeating again. You have to calculate hydrogens attached next to your sp2 carbon. So this carbon is having 3, 3, 2, 8. Next carbon, which is the next carbon to your sp2 carbon? This carbon. This carbon is having only one hydrogen. So one hydrogen for this and three for this. Four hyperconjugation. So tell me number of hyperconjugation in C.
4,
Good. Four. In D.
8.
Okay. So they are asking most stable form, right? So option number B and C are cut. Now from A and D. Now tell me which is more stable enol and why. Both are
Ma'am,
having
D is
8
not enol.
hyperconjugation. What?
Ma'am, D option is not enol form of 2-methyl pentane 3-on.
Okay, so you are going with D. And that girl, what is her name? Dipali or Bhumi? Which is
Ma'am, I say D.
wait.
Hello.
I should remember one or two student name. That girl who was responding from starting of the class, Dipali or Bhumika? Dipali.
Yes, ma'am, Dipali.
Okay, and that who is the boy? Adarsh.
Ma'am, Subham.
Shubham. Okay. So, Dipali, what is your answer? Among A and D, which is more stable?
Ma'am, A.
A. Okay. And Shubham, you?
Ma'am, option A, because D is not enol form of 2-methyl pentanethreone.
And this is not 2 methyl 3 pentane threone?
Yes, ma'am.
Yeah, because this is not enol form of your 2 methyl pentane threone. Yes or no?
Yes, ma'am.
So correct answer is option number A. Because your this only third carbon is oxidized. Oxidized means attached to oxygen. But here in this second carbon is oxidized. So this is not
Yes.
enol form of your 2 methyl pentane threone. Therefore A is correct answer. Good. Both of you. Good. Okay. Now difficulty level will be increasing. Which of the following is the least abundant? Okay, let me read again. Which of the following is least abundant aldol adduct formed from an equimolar mixture of ethanol? Okay, let me write CH3, CHO, and propanone. Propanone is your this. What is the common name of propanone, students? Very common.
Acetone.
Yeah, in aqueous sodium hydroxide solution. This is your simple aldol reaction. Student, they are asking which of the following is least abundant aldol adduct. So, what they are asking? Can anyone explain me what they are asking in question? Then I will explain you. Okay, before answering this, tell me among my simple basic question, among aldehyde and ketone, which is more electrophilic? Or which is more susceptible for nucleophilic attack?
Aldehydes.
Aldehyde is more
Aldehyde.
aldehyde carbon is more electrophilic. So one thing is clear, in your major aldol adduct, this will be your electrophile, this will be your nucleophile. Okay. And question is asking about least abundant. It means they are doing it reverse way, making this electrophile and this nucleophile. I am correct or not? So least abundant will be that OH and CH2CHO. Yes or no?
Yes, ma'am.
Ma'am, can you
Understood?
repeat?
Okay, let me repeat. See, in aldol condensation, student, there will be two things. One thing is you are given 2 moles of acetaldehyde. Okay, in what you will do? One mole will behave as electrophile and one will behave as nucleophile. So obviously, if you see CH3CHO will be in equilibrium with its enol form? Yes or no? OH. And this is your next molecule. This enol will come back and it will attack this CH3, C, OH, CH2, CHO. After workup and all. Are you clear how I am writing this aldol product?
Yes,
Ma'am,
ma'am.
can you please recap this?
What?
Ma'am, I'm asking, can you please recap this?
Okay, okay, okay. See, in your aldehydes or ketones, they are in equilibrium with their enol form. Okay, so among them, that one molecule behave as your nucleophile and one behave as your electrophile, right? So this enol oxygen lone pair will come back. Here negative charge will come. If oxygen lone pair will come back, negative charge will attack onto this carbonyl. If attacks CH3COH, and if you join this atom 1 2 CH2CHO. Okay, let me write step in a stepwise manner. CH3, COH, CH3, C. Now clear? Just for sake of your understanding, I am writing like this. Okay. CH3, this bond will break it as plus minus. Okay. On to this plus, this enol will attack. It will form like this. This is your carbon number 1. So carbon number 1. This is your carbon number 2. So carbon number 2. Now Dipali, understood?
Understood,
Now
ma'am.
intramolecular proton transfer, hydrogen will come here and this will be your, and this proton will be gone, right? And it will become CH2. Okay, okay. Here, okay, my bad, my bad. Here I have done. Okay, here it is aldehyde, and here I have by mistake drawn. I know why you have got confused. Now clear?
Yes, ma'am.
And here no carbon is there, only hydrogen. Clear now?
Yes, ma'am.
Huh.
Yes, ma'am.
Sorry, that was my mistake. Now, now you can easily answer this question. Tell me, when the aldol product will be least abundant, when your ketone will behave as electrophile and your aldehyde will behave as nucleophile, right? So if that will be case, this will be your product, and in which option this product is given? A carbon with two methyl, one OH, one CH2 CHO. Option number C. Yes or no? Okay. If it is not clear, I will explain from zero. No issue. I think you have not taken sir's lecture. So students, aldol reaction. Let's say you are given these two molecules, CH3, aldehyde, and one molecule is CH3CO CH3, right? So there are four possible products. One possible is that your this is from self aldol reaction between ethanol. Okay. This is self aldol reaction between your propanone. In aldol reaction, there are many possible products. You just have to talk about major. Can anyone tell me how this third product is forming? Which is electrophile and which is nucleophile? Students, you just have to do what? In, let's say you are having aqueous sodium hydroxide. In presence of base will abstract alpha proton, right? As in this propanone, this will be most acidic proton. This acidic proton, after base will abstract this proton, carbanion will form. This carbanion is going to attack your aldehyde. So what it will form? CH3COH, CH2COCH3. This CH2COCH3, CH2COCH3. Only reaction between a electrophile and nucleophile. One possibility. Another possibility is base is abstracting this proton and this carbanion is attacking on same molecule of aldehyde only. From there you can get this product. This product is from this same molecule is behaving as electrophile as well as nucleophile. So you will get this product. One possibility is left. Which is that?
When the aldehyde will behave as a nucleophile and the ketone will behave as an electrophile.
Exactly, exactly. Just tell me now you understood or not. I'm trying my best to make you understand. So what you have told me that ketone will behave as your electrophile, yes, and your nucleophile will be aldehyde. Understood. So this will be obviously least abundant. Why? Because aldehydes are more electrophilic than your ketones. So obviously this will behave as nucleophile in majority cases. Possibility is everything. That self aldol are possible. If reaction is taking between same molecule, it will be self aldol. If reaction is taking place between electrophile of one, nucleophile of other, or I can say that if reaction is taking place of by aldehyde or ketone of one compound and enol of other compound, that will be mixed aldol. Okay, both all the products are possible, but major will be where your ketone will be your electrophile and your aldehyde will be your electrophile and ketone will be your nucleophile. Okay, so correct answer is option number C. I hope everyone understood this.
Yes, ma'am.
If not, I can explain again, no issue. Just tell me, can you draw aldol product now?
Yes, ma'am.
Yes, na. How to identify that this is the aldol product? Let's say in any interview someone asks you how you will form this product, what can be the starting material for this molecule. So first you should know if you have form anywhere beta hydroxyaldehyde or ketone, beta hydroxyaldehyde or ketone, that means that is aldol product, right? How to draw its starting material? Just break from that beta hydroxy carbon, right? And give one OH that side and give one hydrogen that side. Just distribute one OH and one H. Left side will become CH3 COH, which can be written like that CH3CHO. This is short trick, okay? Not concept. CH3CHO. Already two hydrogens were there. After getting one more, CH3CHO. Yes, this is the aldol product of CH3CHO. Understood how I am writing the starting materials from product. For example, if someone asks you, what is the starting material for this? Just distribute
Ma'am, how
uh,
to break?
carbon which is attached to OH. Just give it OH and other carbon hydrogen. Now what it will form? CH3CHO plus CH3COCH3. I hope everyone got this trick. You can write na aldol product and from product starting material. You can write both the things. Yes or no? No.
And we can write. Always when we are dividing that, left the carbon with OH will be given OH only.
Huh, yes. This is trick only, not concept. Mind
Yes,
trick.
ma'am.
Like how I will convert that beta hydroxy to its starting material. Because you know that a carbon with 2 OH is equivalent to aldehyde group, right? Okay. Answer is D. Least abundant aldol adduct. In D, what happened? CH3, CH3. D is the propanone dimer, which is destabilized by the steric strain caused by the Gemini aldol reaction and restore. Okay, students, they are saying the least abundant product will be self aldol product of this propanone, right? And they are giving the reason that due to sterics this will be least abundant. Okay, So you can write in your notebook. One factor is, if anywhere your aldehyde is your nucleophile, it will be least abundant. And if they are having these bulky groups, two to sterically hindered groups, then also it will be least abundant. So after D, C will come, okay, in least abundancy. So correct answer is option number D. But I
Ma'am,
hope.
this
Ma'am, not.
What?
ma'am, this will be due to higher steric hindrance, right?
Yes, yes. Therefore, it is. They are saying it will not be possible. It will be least abundant. Someone was
Yes.
saying, Shubham, I think.
Ma'am, please repeat. Not
Okay.
clear about the
Let
area
me
hindrance.
see.
How?
In this question, this was very important question. In this question, what they were saying, there are two things: ethanol, propanol, right? So aldol, there are many possible aldol product. One is your, there are many possible products. One is your self-aldol reaction between your two molecules of ethane. Self-aldol reaction between two molecules of your propanol. Two possibility. Another possibility, ethanol is your electrophile, propanol is nucleophile. Another possibility, ethanol is your nucleophile and propanol is your electrophile. You have to draw all the possible aldol products, and among them you have to tell them least abundant aldol adduct. They are giving explanation is that in adduct D, which is this, it is propanone dimer. Self aldol product are called dimer also, right? Adduct D is the propanone dimer, which is destabilized by the steric strain caused by geminal methyl groups. What will be the what I will say, self aldol product of this propanone? If I write, let me write. You also write along with me. CH3, CH3, CH3. I have to erase some part. CH2, CO, CH3. Right? This will be propanone dimer. Yes or no? What they are saying, students, in order to get this product, they are not talking about product stability, but in order to get this product, two molecules of propanone should come closer to each other. One will be in its enol form, one will be its in keto form only. But these two methyl groups, due to steric strain, they will make this product least abundant. Now you understood. In space, when they will react with each other, these four methyl groups or these geminal methyl groups, they are going to, geminal methyl groups means one carbon having two methyl groups, right? Vicinal means
Yes, ma'am.
two adjacent carbon having those methyl groups. So in these geminal methyl groups are creating steric hindrance for other group to attack onto it. What the reason they are giving? Understood?
Yes, ma'am.
Okay, very good. So problem number 8, which enol form of ethyl 3 oxobutanoate is predominant at equilibrium? Okay, ethyl 3 oxobutanoate. Okay, okay. Let's first talk to IUPAC. Uh, this is a common IUPAC for which functionality? Alkyl alkanoate. For which functional
Ester
group
group.
this is the
Ether.
ether?
Esters, ma'am.
Ester,
Esters.
esters, right? If you are, let's say you are having CH3, COO, or let's say PR, propyl. So what you will call it? Propyl alkyl is group which is attached to your oxygen. Propyl alkanoate carbon chain in your parent chain. So one, two
It,
carbons,
two
ethyl.
carbon.
So its nomenclature will be propyl ethanoate. I hope you are clear with the nomenclature. In longest chain, including your functional group, that chain is having only two carbon. Therefore, propyl ethanoate. Clear? Okay. If clear, try to draw this structure and match with me. Ethyl, okay. O, ethyl. Butanoate, okay, very good. Butanoate means CO. हो गया ना 1 2 3 4 butanoate. This parent chain is clear. 3 oxo. From where you will count? No, counting will start from 1 2 3. 3 oxo. I hope you are clear.
Yes, ma'am.
If I write this structure as per your understanding, this will be like this: COO. Now they are asking about which form of this structure is predominant at equilibrium. Okay, by looking at option, which option you can delete in first go?
A option.
Which? A.
A, ma'am.
Yes.
Okay, okay,
Option A.
okay. This will be deleted. Now tell me, they are asking about predominant. Think.
Option B is predominant, ma'am.
Option B. Okay. Dipali, your answer?
Ma'am,
Okay,
I'm unable to
what
do
is
this
the
thinking.
difference between B and C? Only EZ, right?
Ma'am, in B it is cis and in C it is trans.
See, cis trans you can tell when they are having groups like ABAB, right? But in
Ma'am,
cases
as
where
per
all four are different groups, it is better to use EZ, right? In terms of EZ, tell me B is E or Z? Okay, let's learn today giving EZ. If we talk about this carbon, which will be having more priority, OH or
A,
methyl? OH.
OH.
If we talk about
OH.
this carbon, which will get priority, hydrogen or ester? Obviously ester. So when same
Yes, ma'am.
priority group are on same side, that is Z. When same priority group are on different side, they are E. So obviously E alkenes are going to be more stable or not? Not. Here not.
Yes.
Why? Why?
Ma'am,
In general,
option
listen,
B
in
is
general,
only.
E alkenes are more stable, but here students, this OH can be written it like in this form, and this can be stabilized by this oxygen.
Intramolecular
Huh.
hydrogen only.
1 2 3 4 5 6 6 member transition state is making this Z alkene more stable than your E alkene. So therefore correct answer is your option number B. Now ask me if you are having any doubt. And student, one thing is also clear from here, that which you can, after solving many type of ketoenol questions, you will have this conclusion that whenever one side ketone is there, one side your ester is there, you will make preferentially enol of ketone side, okay, and leave ester side as it is. If I talk about B and D, your answer should be B, not D. Okay?
Ma'am,
Because,
can you please repeat?
okay, I'm saying if you have functionality like this, or I can say active methylene like this, in where one side is ketone, one side is ester. I am saying you make enol form of ketone rather than your ester. मतलब you can make enol form from both sides, but more stable will be from that side where it will be ketone. Can you tell me why? Because if you are making enol form of this side, this carbon is left with ester. This carbon can be stabilized by this oxygen, right? If we compare these two, which carbon will be stable? Obviously this. Stable in means it will be sufficiently electron rich due to this oxygen lone pair. So obviously in between these two carbonyl group, this ketone will like to stay in your enol form. Now understood?
Yes, ma'am.
I'm saying if you are having active methylene of ketone and ester, and they are asking about more predominant form or more predominant enol form, make enol from your ketone side. Between aldehyde and ketone, which will you choose? Now question comes. Between aldehyde and ketone, which side will you choose?
Aldehyde side.
Yes, yes. You are correct. So, students, aldehyde, then ketone, then ester, then your further functional groups. Okay. After discussion from this slide, we will again move to our first question where that aldehyde was also coming. Okay. Remind me at the end of the class, we will discuss that question again. Okay. But I hope you understood this question why Z alkene is more stable than E and why B is more stable than D. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, okay. Very easy question. Aldol condensation will not take place in. Obviously, the aldehyde which lacks,
Formaldehyde.
aldehyde which lacks alpha hydrogen, or aldehyde or ketone which lacks alpha hydrogen doesn't undergo aldol condensation. They undergo which name reaction?
Canizaro.
Yeah, very good. Aldehyde and ketones lacking alpha hydrogen undergo Cannizzaro reaction in presence of concentrated NaOH. Okay. One thing I want to clear you that student aldol reaction can take place in two, which what I call conditions: acidic conditions, basic condition. Just for knowledge, I am telling. Let's say you are given students this CH3CHO and on arrow it is written NaOH. NaOH is your strong base, it will abstract proton, right? It will abstract this proton and you will get CH2 carbon ion CHO. And you can write it like this also, right? Yes or no? Now, this enolate is going to attack your carbonyl of aldehyde. This is one mechanism. In basic condition, you can write this mechanism, student. But in acidic mechanism, whenever there are acidic conditions, you can't draw in mechanism this negative charge, right? Because in acidic condition, this negative charge is not possible. In those conditions, how will you write mechanism? You will draw enol form. Enol form you can write and that will attack onto your carbon. Okay, so this thing is based on concept. In Claydon, I think fourth or fifth chapter is there which in which they have shown how to write mechanism. For competitive exam you should know how to write product. You can write that product easily, right? But when you come to and when you will write your end semester exams, there you have to go by conceptual whatever concepts are there, right? So in acidic mechanism, you can't write this carbon ion because in acidic conditions, how carbon ion will be left in negative form? It will be protonated, right? As soon as anion forms, it will be protonated by your acidic conditions. So remember this thing: in acidic condition, write by enol form, and in basic condition, go by enolate form. Enolate. Whenever it is O negative, it is enolate. When it is OH, it is enol. Understood this distinction between enol and enolate?
Yes, ma'am.
Yes, ma'am.
Very good. Very good. Now tell me, they are asking students which combination of carbonyl compounds gives phenyl vinyl ketone via aldol condensation. Okay. You have to draw this product. How will you get into this product, student? As I have told you earlier, your aldol product is your beta hydroxy ketone or aldehyde. Uh, this, let's say this is aldol product of anything. Okay, how I am telling alpha beta, and then if on arrow it is given heating condition, then what you have to do, removal of H2O, and it will be called your aldol condensation product. This is your aldol product, and this will be your aldol condensation product. Condensation, why? Because here one molecule of H2 is left. Understood how to draw aldol condensation product? If you go to if
Yes.
you want to go back to your aldol product, how you have to do?
Hydration.
Give one OH, give one H. If we come here, pH, CO. Okay, carbon near to oxygen, give hydrogen, and other one OH. pH, CO. Okay. Now what I've told you, draw a line, carbon having OH, give OH. This is by trick. So PHCOCH3 plus HCHO. So without looking at option, you can tell option number A. You can solve this question by directly from looking at option also. That this will behave as your nucleophile and it will attack, and then condensation reaction will take place and you will get phenyl vinyl ketone. Understood how I have solved this question, students? First,
Yes,
from
ma'am.
aldol condensation product, I have drawn its aldol product. From aldol product, I have drawn its starting materials.
Yes,
This
ma'am.
is very frequent question which in interview it has been asked. Students, this is your molecule. What starting material will you use? I have given 2 to 3 interviews. In every interview, have seen this question. In one interview, it was asked how I will form this. Okay, this will be your homework. We will discuss in next question, next class. Please remind. Draw retrosynthesis of this molecule and use aldol reaction. Okay, you can draw na. You have to tell me starting material of this cyclopentanone. Okay. This was the question asked from me in a IIT Bombay interview for PhD. Okay. Okay. The following scheme shows a mechanism for alpha bromination of methyl ketone with bromine in ethanoic acid. In which stage do the curly arrows wrongly show the flow of electrons? Okay. Tell me, students. They are asking in which uh, in which intermediate I can call the arrow flow is wrong. Okay, let me tell you what is the correct flow of electrons. Obviously, if we talk about money will go from rich person to poor person, right? It will never
Yes,
go
ma'am.
from poor person to rich person. Same in chemistry. Electrons will go from lone pair containing atoms to any electrophile, not from electrophile to lone pair. But if you look at structure number 3, instead of going like this, it is going in reverse way. Yes or no? Negative charge is going on to carbon having OH. This carbon is already occupied with OH lone pair, and now again negative charge will come here, right? So option number 3 will be wrong. They are asking in which stage do the curly arrows show wrong flow of electrons. So correct answer will be C. Yes or no? Are you with me?
Yes, ma'am.
Let's have one look at other uh, stages also. Here it is correct. Electrons going from electrons are taking H plus and OAC will take OAC minus. Good. This is correct. Here also this anion is going to take this proton and this carbonyl will have negative charge. It is also correct. This is wrong. Here also it is correct. Negative charge is taking your H plus, so that this oxygen become neutral, right, and will form this alpha bromination product. Slides are not moving. Hmm. So students, in problem number 12 they are asking in which of the following equation is the main product wrong. Is first clear to you? Just before one slide we have done this question. What will happen? Can anyone tell me mechanism for conversion of A, for transformation A? Anyone? Quickly. This is your proton.
First will be protonation.
Very good. This is acetic acid, source of proton. It will activate this carbonyl. Okay, let me write here. It will activate this carbonyl, right? And Br2 is there. After protonation, OAC minus will be left, right, students? This will take a proton from here and it will form your enol, right, students? You are having Br2. Lone pair will come and attack onto your Br. Double bond O, H positive. Oh, sorry, this I will remove. Br and Br negative is left, right? And that then H plus will go from here and HBr will be removed. I hope you got the mechanism, or I was very fast. Can anyone tell me the mistake which I have made? This. Understood, everyone? Let me again tell you. First, acetic acid will protonate your carbonyl. After protonating, this carbonyl has become now more reactive. Why? Now these hydrogens have become acidic. So that OAC negative can abstract this proton. After abstracting this proton, this will go here and it will form enol. Lone pair of oxygen will come back and this center will attack onto Br positive. Br negative will be left. At last, this double bond OH positive, it will leave H plus, become neutral, and H plus and this Br negative will leave as HBr, and you will get this alpha brominated product. I hope mechanism is clear.
Yes,
Clear?
ma'am.
Okay. Thank God. Tell me B. Is B correct? Oh, answer आ गया गलती से, sorry. Have you seen answer?
Yes, ma'am.
Okay, but let's discuss other option also. CH2 OH OH. What you can write? Diol can be written it like as your this is your formaldehyde, right? So this is your nucleophile, this is your formaldehyde, and few slides back we have seen a phenyl vinyl ketone. Since here heating is not there, therefore they are stuck to aldol product. See, beta hydroxyketone, alpha, beta, correct? So option number B is correct, option number A is correct. Option number C you do by yourself. It is which name reaction is this? Claisen condensation reaction. Claisen condensation is Claisen reaction. Okay. You draw mechanism for conversion C by yourself. If you are not clear, please remind me in next class. I will explain again. Let me give you hint for this. You have to abstract proton from alpha side. Okay. One, 2, 3, 4, 5, 6. Intramolecular condensation reaction will take place. This carbanion is going to attack this carbonyl. It will form O negative. Negative charge of oxygen will come back and OAT will be leaving. I hope by this explanation you got how to write. Yes or no? Students, is it clear or I should explain again? Not clear?
No, ma'am.
Not clear. Okay. Sodium methoxide is there. Ethanol is used here as solvent. Okay. You have to write by your own, but I'm just telling. Sodium methoxide base, what is the function of base? To abstract a proton. Base will abstract proton from your alpha carbon. Carbanion will form, right? Now you see, you have nucleophile. You have electrophile in your same molecule, right? So 1, 2, 3, 4, 5, 6. A 6-member ring will form. This negative charge is going to attack onto this carbonyl, right? If it attacks here, this will become O negative. O negative charge will come back and it will eliminate this OET negative and will result into formation of this product. Now clear?
Okay, ma'am.
Yes, ma'am.
Sure na? Simple reaction. Just taking alpha proton and attacking onto the uh, remember student, intramolecular reactions are always fast. Okay, and formation of 5-member and 6-member is stable. Okay, why D is wrong? Because student, what they are doing is nitrogen lone pair pushing and then this negative charge is attacking onto this and forming this iminium ion. But explanation, what explanation says to you, you can write it in your notebook by red pen. Enamines undergo alkylation mainly at the nitrogen with simple primary alkyl halides. C alkylation is successful only with reactive alkylating agents. So you can write it in your notebook. If you are having alkyl chlorides and you are having enamines, nitrogen lone pair will directly attack onto this. Not carbon, not alkylation will take place from nitrogen side, not from carbon side. Understood? These things will help you to solve questions which will appear in your competitive exams. I hope you all are in majority is from BSc stuff, right? So after 3 years you are going to write your JAM exam for getting admission into IITs for MSc. So from now only start preparing for those exams. Okay. Can you do this as your homework? It's a simple aldol based problem. Yes or no?
Yes, ma'am.
What you have to, how you can practice this type of question? You form all the possible aldol product, then their aldol condensation product, and see the stability, right? But one basic thing what you have to keep in mind is, whenever aldehydes and ketone are there, the major product will be when your aldehyde is electrophile and your enolate will form from ketone. This enolate is going to attack here, then you can get the product. Okay.
Yes,
Understood.
ma'am.
Very good, very good. Which of the following reactions shows a correct main product? Okay, tell me. Take your time. Before telling this thing, student, let me clear one thing. Whenever you are having bulky bases, bulky means, let's say it is written LDA, lithium. Okay. Okay, do it as your homework, student. Find full form of LDA, LITMP, LDA, LITMP, HMPA, and what more? Okay, lutein. Google their structures, okay, and see their structures. It will be helpful. For now, I am telling this is your bulky base. So there are two enolates possible in these cases. One is your this product, and one is your this product. Among A and B student, which is more stable? A and B, which enolate is more stable? Tell me, is it that much hard? What happened? Dipali, Shubham, am I audible?
Yes, ma'am, you're audible. Can you
Okay.
please show the structure?
Huh. I'm asking, among A and B, which enolate is more stable? A na?
Emulate A.
Huh, because it is having more hyperconjugation. But
Yes, ma'am.
but let's say you are having bulky base. So which proton is easy to abstract? This proton, methyl carbon proton, or this right side proton or left side proton from B?
Right side.
Right side, because this proton is easy to abstract. Okay, so first step is base is going to abstract your proton. So the step which is easier and that is giving product, that is your kinetic product. This is stable product, but from here taking proton is a tedious task. So therefore it is why it is thermodynamic product? Because it is more stable product. And why it is kinetic product? Because here taking proton is easy, because it is least hindered proton. So this is your thermodynamic product, this is your kinetic product. So students, there are two types of bases in organic chemistry: bulky base and another is your hulky base. Hulky is you will not get these type of bases in your books. This is my term. Hulky means lighter base. Okay, bulky base are going to give you kinetic product. Lighter bases are going to give you thermodynamic product, right? Moreover, there are temperature dependent things also. At minus 78, you will get your kinetic product, but as you increase temperature above zero, you will get thermodynamic product as well in your bulky bases also. Understood? Okay, let me repeat. Bulkier bases are going to give you kinetic product at low temperatures. At low temperatures, kinetic product will form. At higher temperatures, thermodynamic product will form. If you want that you can get kinetic product, you should put your reaction at lower temperature by using bulkier bases, right? But if you want to get thermodynamic product, use lighter bases and increase the temperature of the reaction, you will get thermodynamic product. Clear?
Yes, ma'am.
Okay. So if you understood this thing, forget about A. Tell me, is B correct? And I'm telling this base is bulkier. Now tell me, is B correct?
No, ma'am.
Yes. Because at minus 78, this will form kinetic product. It will form enolate from right side. Okay. So this is wrong. Is C correct?
Yes, ma'am.
C correct. Okay. Is D correct? Okay, I'm telling first one is correct.
Ma'am, D is also correct.
Sure. Do you think PHBr is a reactive alkylating agent? Do you think PHBr is your simple bromobenzene? Will this carbon
No,
wants
ma'am.
because this carbon will not be that because here you can't have partial positive charge, right? So one thing is clear, that this alkylating agent is not that much reactive, right? So what you can do is you can increase the reactivity of your nucleophile, because you can't do anything in your electrophile. So if I talk about carbon ion, here O negative is there and here C negative, which will be more reactive among O negative and C negative? O negative, student. So therefore here this O negative will attack onto pH and will form OPH. Okay, understood what I have told you? Here this product will form. Why? Because your electrophile was not that much reactive, but we have our anion reactive, that is O negative. Here HSAB principle comes into picture. HSAB principle. Read by yourself. According to HSAB principle, hard acid goes with hard base and soft acid goes with soft base. Okay? Okay, let's get to last question of today's session. Okay, first question, is it correct? Okay, let me read question for you. Which of the following equations does not indicate the correct mean product? A student, in first, what will happen? Catalytic H plus is there. It will protonate this. Okay. Obviously, this is going to attack onto this carbon. What it will form? PH, COH, CH3, N, Me, Me, H positive, right? Then what will happen? IMPTR. What is this? Intramolecular proton transfer reaction. Intramolecular proton transfer reaction. So what will happen? PHCOH OH positive NMe this. Clear, students? Intramolecular proton transfer. This H plus will transfer to your OH because your OH is your good living group. Nitrogen lone pair will push ahead and leave this H2O molecule, and you will get this enamine. Okay, I hope you understood this thing. Clear?
Yes, ma'am.
Hmm. So first is correct. They are asking about does not indicate correct main product. Is second correct? Iminium ion can be transformed to ketone after workup and hydrolysis. Is second correct? Yes.
Ma'am, what is PHF?
Where? PHH? Where?
Ma'am, in B it is written first THF.
Okay, okay, sorry. THF. THF is solvent, tetrahydrofuran. Okay, this is your tetrahydrofuran. Short form. THF is used actually in Grignard reactions or these type of reaction. Majorly this solvent. Okay, okay. Let me ask you. In organic chemistry, we can use acetonitrile, ethyl acetate, petroleum ether. But can anyone tell me why in putting Grignard reactions we are deliberately using diethyl ether or THF, tetrahydrofurans? Can anyone think of any reason?
Ma'am, because I think the reaction gets somewhere hindered when there is proton or water present, something like this.
Exactly. See, in Grignard you are having your nucleophile, and let's say you are using ethyl acetate as solvent. Then instead of that nucleophile attacking your substrate in which you want reaction, it will attack carbonate of your ethyl acetate, right? So you will not get your product. You will get multiple products for that. Therefore, in those cases, you have to use solvent in which there are functionalities which can't be affected by external nucleophile. Okay. Therefore, in these Grignard type reactions or these aldol condensation, etc., you use THF instead of using ethyl acid. Good. So, students, let me solve this question quickly. Nitrogen lone pair will come back and C alkylation will take place because this is also reactive and this is also reactive, and you will get this product. Okay. In this case, what will happen? Triethylamine will take this proton and attack here, and you will get this. Is it correct or not? Option number C. Students, whenever you are given trimethyl chloride, remember this thing. You can note down in your copy also. Whenever you are having trialkyl chloride, O alkylation will take place. Okay, not C alkylation. You can read about this in Claydon. Okay. In D option, is this correct product? But student, one thing you are look if you can see in C that OSIME3 has transferred from this carbon to next carbon, right? This can't happen. So option number C is wrong. Understood what I am telling you? As per this theory, this can be possible that you are forming this OSIME3. But this is not possible. Oxygen can't transfer from this carbon to this carbon, okay? Therefore, C is wrong. Now tell me, what about your take on D? Is D correct? Oxygen lone pair students will go there and see alkylation has taken place. It is correct, right? Because this alkyl halide is reactive or not? It will be reactive, right? Because it will be benzylic carbocation. Yes or no?
Yes, ma'am.
Huh. So this is correct. So correct answer is C, because here oxygen is migrated, which is not possible. Okay. So students, in today's or week 5 lecture, and we have covered ketoenol tautomerism. We have learned how to make what is tautomerism or ketoenol isomerism, 1,3 hydrogen migration. We have seen in which cases enol content will be more than their keto form. In general, keto forms are more stable due to more bond dissociation energy of C double bond O rather than C double bond C. And we have covered aldol reaction. I think in next session we will cover other reactions like Cannizzaro condensation. Just wait.